In this article, we present our experience with the use of educational robotics in teaching mathematics for life for special educational needs students. This work deals with the use of robots as artifacts for learning mediation in Mathematics for Life, a math course intended for students with special educational needs, aiming at the development of knowledge and abilities that enhance their personal and social skills, promote autonomy, and assist their integration into society. For this to be possible, students need to experience mathematically rich situations and use mathematical concepts in the interpretation and modeling of real situations. The expression special educational needs refers to all kinds of difficulties that may cause problems during the learning process, whether they are physical, sensorial, intellectual, emotional, social, or any combination of these. This research was done in a natural environment using a qualitative methodology. Participant observation was the main strategy and acquired the status of data collection method. The collected and analyzed data emerged from the participation of 2 female students with special educational needs while constructing a learning scenery for activities with robots. Data collection was carried out in a classroom environment during 4 months of 2014. A logbook with detailed observation notes, conversations, and dialogue recordings was constructed, and audio and video recordings of the lessons were also made. While the students were building the scenery and the robot, the concepts of perimeter, edge, area, and units of measurement emerged. When they had to move the scenery to a presentation room and change the bus route, which implied modifying the previously developed program in terms of time, they demonstrated the ability to solve problems. The cut, paste, and fit processes necessary for the construction of the scenery and the robot contributed to the development of the psychomotricity. The students, working in groups, had to share opinions, learning to respect, choose, evaluate, and decide. The programming of the robot involved the acquisition of different knowledge and allowed the development of students' personal and social autonomy, since the school's community a priori did not have the expectation that they would be able to program robots. Creativity allowed us to overcome the barriers of reality and create a story. And imagination allowed them to explore other alternatives and foresee possible futures. The construction of the scenery for the bus route was the physical reproduction of what they had imagined and demanded a sequence of actions that they had to control. This enabled reflection and understanding of the options that were taken throughout the process and helped them to describe situations and communicate findings and mathematical and other ideas using oral and written language appropriate to each situation. Elsie Santos holds a PhD in mathematics, a master's in multimedia education, a postgraduate diploma in mathematics education, and a bachelor degree in mathematics. She is an assistant professor in the Faculty of Exact Sciences and Engineering and director of the master's program in mathematics teaching at the University of Madeira. Regina Alves is a mathematics teacher at primary and secondary school of Santa Cruz in Madeira.